See, let's do an example 7 of effective rate example. When interest rates are low, as they were when this text went to press, the interest rate and the APY are insignificantly different. To see what the difference is more pronounced, we will find the APY for each of the given money market checking accounts which were advertised in October 2008 when offered rates were higher. So the banks are offering this 3.35% compounded monthly, the Imperial Bank, and the US Bank is offering 2.33% compounded daily. Now, US Bank's rate is looking quite a bit lower than the Imperial Bank, but compounding is different. So we want to see the effective rate of both cases. So let's talk about Imperial Capital Bank first. How do you calculate the effective rate? I want to show you the calculator thing. So you will use this app EFF. At the first place is always the actual rate which is given, and the second place is number of times it's compounding, that is monthly, meaning this is 12 here. So let's use the calculator. The app is under apps and finance. Go down in the list at C, select that 3.35 comma 12, enter. So 3.35 is actual, effective rate is 3.40%. Now let's talk about US Bank. Their effective rate should be EFF at 2.33 comma compounded daily. So this number is 365. Let's try that. Apps, finance, go down the list to EFF 2.33 comma 365. 2.357%. So 233 is actually 2.357% and 3.35 actually is 3.40%. Effectively, not actually, effectively, right? That is how it affects the interest rate. Next we have another example. Keisha Johns must pay a lump sum of $6,000 in 5 years. What amount deposited today at 6.2% compounded annually will amount to $6,000 in 5 years? So this is a kind of a question of present value. So they are asking us to find present value when the future value is given to be $6,000 in 5 years when compounding is done annually. That means n is 1. So we know the formula, future value meaning the amount is equal to principal present value plus 1 plus r by n raised to power nt. Now in this case we know the amount, which is 6,000 is equal to, I do not know the principal, 1 plus interest rate is 6.2%, meaning 0.062 in decimal. So that is what we write here, divided by 1 raised to the power 5 times 1, which is 5. So if you see, this thing looks like 6,000 is equal to principal times 1.062 raised to the power 5. So we can calculate this number and divide both sides by that. So the principal is 6,000 divided by 1.062 raised to the power 5. Let's see. Divided by 1.062 raised to the power 5. So how much amount he should have today, which will become 6,000 in 5 years? The answer is present value of that 6,000 is 4,441. Example number 9. A zero coupon bond with face value of 15,000 and interest rate of 6% rate, compounded semi-annually, will mature in 9 years. What is the fair price to pay for the bond today? So the question again is to find the present value when the future value is given to be 15,000. Interest rate is given 6%, meaning 0.06, and time is given to be 9. In compounding is done semi-annually, that means n is 2. So you can also use this formula, present value is equal to future value divided by 1 plus r by n raised to the power nt, right? Everything is given here on the right hand side. We can find your present value, which will be equal to 15,000 divided by 1 plus 0.06 divided by what? 2 raised to the power nt. So 2 times 9. You can use calculator. That would be 15,000 divided by 1.03 raised to the power 18. 15,000 divided by 1. So today he need to pay how much? 8,810 approximately for the bond, which will pay him 15,000 in 9 years at the interest rate of 6%. The last topic here is continuous compounding. So until now we did compounding annually, compounding semi-annually, monthly, daily, weekly, right? What if there is continuous compounding? So future value of the present value after t years under continuous compounding is given by this formula. As I repeatedly said, I sometimes write p in place of present value, then it will be p times e raised to power rt. Let's do an example of that. Find the compound amount and the interest rate earned when the following investments were having continuous. So please remember, this is the question of continuous compounding. Okay. So what does that mean? Principal is given to be 20,000. R 3.5%, meaning 0.035. T 5 years. The amount, or you can say future value, is given by the formula principal times e raised to power rt. Principal in this case is 20,000 times e is an exponential number raised to power 0.035 times 5. You can use the sorry, you can use the calculator here. So that will be 23,824.92 in 5 years at the continuous compounding. They also asked us to find the interest. So the interest always is the future value minus principal. So that means this minus 20,000. What will be that? 3,824. That much is the interest earned in 5 years at continuous compounding.